Hey everyone, how's it going? This is Andrew over here at Adyen, and today I'm going to be showing you how to integrate drop-in on your e-commerce website. Drop-in is the quickest way to offer tons of different payment methods on your website, and the best part is that you don't actually need to build out each payment method individually. It's kind of an all-in-one solution. So what you're looking at right now is the documentation for web drop-in. You can check it out at docs.adyen.com. But rather than going through the documentation, let's actually go through a visual example of the app that we're building today, so you can kind of see a visual demo of drop-in. And this is the app that we're building today. It's called My Store, and what it's supposed to represent is a mock checkout page that the shopper would normally see when they want to make a transaction. So on the left side, you see the billing information for the shopper to fill out, but on the right side are all the different local payment methods that the shopper can choose from. These are all the different payment methods that drop-in renders on the page, including all the input fields and all that. So you can see here we have Alipay, we have credit card, we have Boleto. Scroll down a little bit, we have GiroPay, Ideal, Klarna, SEPA, WeChat Pay, so on and so forth. To give you a quick summary of how this works, when your shopper visits this checkout page, your server makes an API call to Adyen to get a list of available payment methods for the shopper. At this point, the shopper selects a payment method from that list and enters their payment details in the input fields rendered by drop-in. When the shopper selects the Pay button, your server uses the data returned by the client to submit a payment request to Adyen. If the response requires additional action from the shopper, drop-in can handle all these additional actions. In such cases, your server will make another request to Adyen to complete or verify the payment. If there are no additional actions required, the payment result can be presented back to the shopper. So this means if it's an authorized payment, a refused payment, if there's an error, all of these different outcomes can be presented to the shopper. So what we're building today is first the server to handle all our shopper interactions. The endpoints on the server are going to be custom routes that interact with the Adyen API at specific points in the checkout process, and your client accesses these endpoints through simple fetch requests. Each endpoint is going to return a JSON response back to the client, with the exception of one of the endpoints, which is handle shopper redirect. After building out the backend, we're going to jump back onto the front end and implement it using some ready-to-use drop-in UI components. We're going to add some Adyen scripts and styles to the checkout page. We're going to create some fetch requests and event handlers to handle any client-server interactions. We're going to configure and instantiate drop-in mounted to your checkout page. And then from there, you're pretty much ready to start testing transactions with a ton of global payment methods. Let's get to it. Now, rather than building this app from scratch, let's use some of the boilerplate code given to us. You can check it out right here in my personal GitHub, where I actually broke down the complete app piece by piece in these 13 commits. Basically what I did here was scaffold a Node.js Express app, so if you've used Node.js Express before, none of this should seem unusual. We're using handlebars as our template engine. We're using .m to give us access to environment variables in our .env file over here, which you can see on the left side file tree. What we're also doing is using Morgan to set a request logging. We're using UUID to give us some unique identifiers that we're going to be using later on. And of course, we're going to be using Express. Along with all the setup over here, we're serving all our client files from the public folder. We're enabling environment variables over here. We're setting the template engine to handlebars. And in terms of the server, it's going to be served on port 8080. Now, in terms of that boilerplate code, what you're also getting is this public folder on the left, which comes with some CSS that we're using in the app. We also have a bunch of SVG images. And the view folder is just going to hold all our client code. So we have our main layout over here, where everything's going to be rendered over here in this body. We also have our customer form, which is just all the hard-coded information like first name, last name, address, basically everything to make the page look like a checkout page. But just to be clear, none of this has to do with any drop-in logic, meaning that first name, last name, street address, city, none of this stuff is actually going to be sent in any API request. So in other words, all this stuff is just flair to make this page look a little fancier. We also have our payment result pages for the transactions, Earlier we saw the success page, which is just the quick outcome for the shopper to see. Now let's get the show on the road and start building out the server. I'm going to jump right back into that server file right here. And again, what the server file is going to do is handle all shopper interactions during this checkout process. I'm going to collapse the file tree real quick just to give us a little bit more focus. To interact with Adyen's API during the checkout process, we're going to be using the Adyen API library made for Node. So let's go ahead and import that. From that library, we're going to be pulling out the client, config, and checkout API classes and doing some configuration on those. We're going to instantiate a new config object. We're going to be adding our API key from that env file to our config object. We're going to instantiate a new client object, passing in our config. Set the environment to test. And then finally instantiate checkout, passing in our client. Now that we have all that, let's build out our first server endpoint, which is getting payment methods. Again, what this endpoint does is to get a list of available payment methods to present to the shopper. This call is going to be made when the shopper visits our checkout page, so let's do an app.get right on the root route. Inside this get, we're going to do a try catch. And we're going to make a payment methods call passing in two parameters, channel, which is going to be web, and our merchant account, which we're going to grab from our env file. We'll use that response on our payment template that we're going to be building out later on, passing in some data from our server to our client, in particular the client key and the response itself. And in terms of error handling, we're just going to print it out to the console. Great. So now that we have our payment methods, let's go ahead and build a server endpoint to initiate a payment. First, keep in mind that some transactions need additional payment details, and they may even redirect you to a different page to provide that info. So let's create a temporary store to keep that data. In a real production application, this should be stored in a database, but just for the simplicity of this test demo over here, we're going to be putting it inside a hash. On our server, let's create a post route to initiate a payment. We'll then generate a unique order reference that we're going to be using in this transaction. Then we're going to make a call to the payments endpoint of the Adyen API. Keep in mind that ideally, the data passed in here should be computed based on business logic, but again, just for the simplicity of this app, we'll hardcode some of the values ourselves. Now, specifically for this demo, we want to make sure that 3D Secure 2 transactions are enabled. So let's set that to true right here underneath additional data. We also passed in a return URL, which is the URL that the shopper is going to be redirected back to after completing 3D Secure authentication. After we get the response back from this payments call, we're going to pull two pieces of data from it. First, the result code, and then the action. The reason why I set action to null is because for some transactions, no additional steps are actually needed to complete the payment. In this case, the response from the payments call actually would not contain an action object. And from here, all you need is a result code to present the payment result to your shopper. In other cases, if you do get an action object back in your payments response, what this means is that the shopper needs to do additional actions to complete the payment. So let's make sure that scenario is also covered. This way, if there is an action required on this transaction, we're going to set that data as the value for our order reference. And at this point, let's return some JSON back to our client. So at this point, we built out all the logic to initiate a payment, but what happens when there's a redirect needed to complete the transaction? Let's go ahead and build that out. Let's create an all route so we can get to it and post to it, and we'll call it handle shopper redirect. Now, the endpoint that we're going to interact with on the Adyen side is called payment details. So let's first create a payload for submitting those payment details. This data actually comes from different parts of the request based on which HTTP method that we're using. So if it's a GET, we're going to be grabbing it from rec.query, and if it's otherwise a POST, we're going to grab it from rec.body. Now, let's build out the rest of the payload. What we did here was grab the order reference from our query params, retrieve the data from our store, and then we deleted it after using it. Now that we have the payload built, let's make the call to payment details. When we get the response back, we're going to conditionally handle different result codes for the shopper. In other words, let's switch on the result code in the response and render different payment outcome pages for the shopper. Again, these different payment outcome pages are the same ones that we provide in the boilerplate code. So after making the payments details call, and if we get a result code of authorized, for example, the shopper is going to be redirected to the success page. And in case something goes wrong, let's just output that error onto the console. We'll also make sure we cover this by adding client-side endpoints for these result pages. So at this point, our server is well equipped to handle any shopper redirects. Along with the redirect, there's actually one more scenario that we should cover, and this is when the shopper is required to perform additional actions without leaving the website. So, for example, when the transaction needs a native QR, like in WeChat Pay, or in overlays, such as in PayPal transactions, we want Drop-in to be able to send these payment details as well. So we're going to build out our final endpoint on the server. We're going to post to this endpoint, and let's just call it submit additional details. This is actually going to look pretty similar to our previous endpoint, where we handled shopper redirect, but we're going to be building out the payload a different way and handling the response a different way. The payload is going to have two different keys, details, and payment data, and let's just grab both of them from the request body. After we make the call to the payments details, we're going to return the response back to the client, where the client is going to do some further action handling, or if there's no action, present the result back to the shopper. So again, similar to initiating a payment, we're just going to pass a result code and an action back to the client as JSON data. Cool. Now at this point, the server is pretty much built out. We handled all the various different shopper interactions that can take place during the transaction, including getting payment methods, initiating a payment, handling any redirects that are needed for that payment, and also handling any additional details that need to be submitted for the transaction to be complete. With the server fully built out, now we can start building out the front end for drop-in. To do that, we're going to jump back into our documentation for drop-in. If we scroll down a little bit all the way to add drop-in to your payments form, you actually have your choice of using the Adyen Web Node package, or you can go ahead and use a script tag. Let's go ahead with the second approach. We're going to go ahead and copy the script and add it to our main template page. Open up the file tree, and add it right there underneath Bootstrap. Jump back to our documentation, and do the same thing with the CSS file. Again, the CSS file has a few default styles for drop-in, but feel free to override any of its classes. You can get more information on that right here, right in the documentation. Great, so I'm going to close back down the file tree. And what we're going to do next is create the payment page that we referred to over in the server file. Recall that in the server file, we referenced a payment template that we haven't built out, in which we pass from the server the client key and the response. So at this point, we'll build out that page. I'm going to open up the file tree and create a payment template underneath the view folder. Close it up. And the first thing we need to do is create a few hidden divs with the data that's passed from the Express server, namely the response from the payment methods call and also the client key. Next, we're going to create a div onto which drop-in will be rendered onto. You can actually name it whatever you want, but to be a little bit more explicit, we'll just give it an ID of drop-in. And in terms of the hook, that's really all you need. But again, in the context of the sample app that we're building, we also had a customer form in there, as well as a few other pieces of custom styling, which you don't actually need per se. But just to make it look like what we demoed earlier in the app, we'll go ahead and use some of those elements. So just to be super clear, these are just some of the custom files and CSS classes and IDs for this particular app. You don't actually need any of these extra divs or the customer form partial for drop-in. It's all just for styling our demo app. Great. And the last part that you really need for the file is the Adyen component client code. And rather than putting that all into this page, we'll go ahead and create a new JavaScript file and reference it here using a script tag. Next, we're going to build out the file. Recall that a lot of the client code is going to be served via the public folder, so we're going to create the Adyen implementation script right there. Close it up. And in order for our client to be able to interact with our server, we're going to facilitate all that using some fetch requests and some event handlers. So for the first part, we're going to create a function called callServer, which will make a post request via fetch and return back some JSON. Now, in terms of the responses sent back from our server to the client, recall that we can expect anything from a result code to an action. So we need a way in our client to handle the server response. Let's go ahead and build that out. First, we should check if the response includes an action, in which case, drop-in can handle that action directly. Otherwise, if the response includes a result code, we can have the client present that outcome to the shopper. So in this case, if we get an authorized result code, we'll have the client redirect the shopper to the success page for a successful transaction. Similar goes for some of the other result codes. Now, there are other result codes that are possible, but again, for the sake of keeping this app small, we won't build that out in this video. So after building out how the client and server interactions are facilitated, what we need to do now is handle what happens when the shopper selects the pay button, or what happens when additional information is required to complete the payment. We'll call this function handleSubmission and pass it our state, drop-in, and URL to which we're reaching out to. Now, of course, all this function is really doing is calling some other functions, but this is actually pretty deliberate in our demo. We just wanted to make sure that every single interaction between our client and server are noted explicitly right here in this script. Now that we connected to our server and created the event handler, what we have to do next is configure drop-in. Recall that in our server file, we made a call to the payment methods endpoint and sent back the client key as well as the response for that call. We stored that data in a hidden div on the payments page. And now what we're going to do is use some of that data to configure drop-in. We'll jump back to our script file and do just that. First things first, let's store some of the data into a variable. When you create a new instance of drop-in, it takes in a configuration, so let's put that together. First, we'll give the payment methods response as well as the client key. And I also want to accommodate the United States English in a test setting. Next, what you can also do is configure payment methods individually. Payment methods come with their own default configurations, but in case you wanted to override some of those defaults, you can go ahead and do it right here. For example, if I wanted to make sure that there's an input field for the holder name for credit card transactions, I can set that to true right here. Now, there are other ways that you can further modify and configure drop-in, and you can check that out all on our documentation or API Explorer online. One final way that I want to configure drop-in is to assign the event handler that we created to a few specific events. In particular, what happens when the shopper clicks the pay button, and also when additional details are needed to complete the payment. So now that the configuration is complete, the final step is to instantiate and mount drop-in. All we have to do is create a new instance of Adyen checkout, then pass in our configuration. Then we'll create drop-in, then mount it onto the drop-in div over here on our payments page. And that's it. Now, we actually just wrote a bunch of code without rendering anything or testing anything, so let's make sure everything works out. I'm going to first start the server and then check out what happens on port 8080. And there you have it. Now you're able to offer a number of different payment methods for your shopper on your website. So we had a 3DS2 payment earlier. Let's check out what happens if we chose Ideal. And it seems like there's a slight issue. Let's check out what's going on here. Drop-in on handle action is not a function. So that's in our Adyen implementation script. Let's see what's happening in there. There we go. So we called the parameter the component, but over here we're calling it drop-in for handle action. Let's check back in and see how things look. Go back down to Ideal. So we got redirected to a page to complete the payment. Hit continue. And we see our success page. And that's it. One last thing to keep in mind is if you want to check out this video in a tutorial format, you can jump back to our documentation and check it out right there. We have the Node.js Express tutorial listed right over here on the left. If you have any questions or feedback about drop-in not covered in our integration guide or our tutorial or this video, feel free to reach out. Otherwise, take care everyone.